what I want to share for now. It seems like we forget that the actual main problem that we have is actually questions like this. Am I wrong? I just selected this one
No.
because after the normal ones that we normally do, but when we when we talk about the true reflection of what proves if you are ready for your first paper or your second paper, that one thing that proves if you are ready, it's if we are able to answer questions like this. Now, um, for the time we're doing functions, we had to, at some point, we had to complete the square. At some point, we had to do some stuff, J. And we don't know what was the reason of us completing a square. We're just doing it there. But now, when you look at this diagram, how many of you feels like if I look at this question, this is nothing, I can kill it? It's worth it's worth uh it's worth 16 marks. How many of you would say I would get all the 16 marks? How many of you feel they would get half of the marks at least? Okay, how many of you feel they would get at least 6.1? No one, eh? Or it's just because it's not a one-on-one lesson. But it's okay. Um, Here we have the situation. The graph of f of x is equals to minus x squared minus 6x, and g of x is equals to ax squared plus bx. Oh yeah, the c is 0 in this step. They are drawn below, as we see. And g is the reflection of f along the x-axis, as you can see the way it rotated, like goes exactly. A and B, A and B are symmetrical on f along x is equals to minus p, whatever value that line is. But I think you already have a clue where that line x minus p is going to be at, ne? This, like, what I'm asking is, do you have a clue where this equation is going to be at? Like, do you have an idea where after the information when they say A and B are symmetrical on F along X, and then um, the along the X along the X axis of symmetry? My question is, can you, if you were to, just since we, if we were to construct this P minus 1, do you have, is there anyone who has an idea where does it belong? Where can it be? Where can we construct it somewhere there? Since it is a reflection, I mean, since it's symmetric, since A and B are symmetrical about that axis. Anyone going once, going twice? Come on, guys, prove to me, Hori, at least we are participating, we are not sleeping. Because how sure am I? You've left your laptop on, we've left the laptop on, and you are scrolling on Facebook and Twitter.
I'm not sure.
Sure.
Yeah.
Answers like this are acceptable. And like blue ticking. Answers like this are very much acceptable. I think so normally if we were to have an equation and then um it goes in the form of maybe a graph like that, and then we have a point there which would be A, and then we have a point which should be B. And suppose we are told that there is the they are both symmetrical, but the reflection is, it would be the x-axis. It has to be exactly in the middle. So a reflection is like, you think of, a reflection is like, you think of this position, you think of this position as if it is looking at itself in a mirror, and the object would be there, which would be staring at itself in a mirror. So the mirror has to exist, it has to be there. That's the mirror. It's more like a mirror image type of a thing. So if this point is symmetrical to this point along the line x is equals to minus p, it means minus p would be exactly somewhere here in the middle, minus p, such that that line would be crossing there. And if it crosses there, it should tell you something regarding, it should tell you something regarding a parabola. Come on, guys. We've been doing parabolas from the past. I know you might not want to answer, but what do we call this point here in terms of a parabola where it's turning?
Is it the amplitude?
Mm-mm. It's the turning point of the graph. That's where the graph, it's a, remember, we are dealing with, it's maybe, let me reframe, let me start by saying this is a quadratic function. The very same one that you know, which is f of x is equals to ax squared plus bx plus c. That's a quadratic function. But this time around, the one that we have is f of x. Let me just use a different color there. The one that they gave us on this question is f of x is equals to minus x squared plus, no, minus 6x. So in this regard, that's how you know a is equals to minus 1, b is equals to minus 6, and then c is equals to 0 on our given equation based on how they brought it in a question. So it is the very same quadratic. It's just that the value of c happens to be 0 this time around. But anyway, if normally, if you know your story, you would know that c represents the y-axis somehow. So since c represents the y-axis somehow, the graph that we have for f, sometimes I feel like here's the thing. The most important thing that we miss sometimes is the moment we see a graph, we look at the graph with one eye, and it's always something similar that we would normally know. Like the graph would be something that we know already. So we look at the graph, it's already something that we know, but we bypass the most important thing, because the moment we look at the f of f, the moment you look at f of x as it's given, your mind must allow you to see that graph is because of the f of x. And you must, whatever question you do, you must identify the type of graphs. Hence, we learn the type of graphs ka 1, 1, separate. And the beautiful thing about this one is it has parabolas only. That's why I chose this one. Although we have two that are reflecting each other, but somehow they are just two parabolas, which is two quadratic functions. Now, from the past, as we were learning quadratic functions, what was the punchline? The punchline was, if you have a graph like this and you have to draw the graph, you would have to find the y-intercept, which is just one value. And then it's going to have two values of the x-intercept because you're going to factorize. And then it's going to have a turning point. So the turning point, this time around, since they are saying, we haven't answered this question, we haven't answered any question yet. We are just analyzing the diagram based on how we know, which is the exact thing that you must do. Should it be mathematics? Should it be physics? I always say, if you are given a question that has a diagram, read the paragraph that concerns the diagram, ignore the question at first. You can take like 2 minutes and ignore the questions. Look at the diagram. Try to pick up things that you think you can see yourself. Like, not that you are predicting the questions, but based on your knowledge, you can see what sharp. This is a quadratic function. Somehow it must have a turning point. Somehow it must this and this and this and that. So sometimes I feel like we have gotten to a point where, because we know that mathematics is challenging, we get to a point where we just use our memories for whenever you have a quadratic, da, 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 da. But it gets to a point where the only way to focus on the object, or rather the only way to dig out as much information as you can, is to give yourself time with the diagram before you do anything. Because what I was saying is just that I got carried away there. But what I was saying was, based on this function being f of x is equals to minus x squared minus 6x, I already know if I was to find f of 0 would be 0. Hence, it is passing through 0 exactly there on that point. You see, those are just useless things that I'm just observing, Jay. But already, since ax is equals to, since c represents the value of y vele on a parabola or on a quadratic function, I already know c is 0. That's why it passes there. But all that information is just in the name of analyzing before we answer anything, to boost our confidence, just to know we are killing it. Ne? All right, let me remove everything as if we never talked about it. Now let's approach the question as if we are approaching it. The confidence will come after. So the graph of f of x is equals to minus x squared minus 6x, and g of x is that. They are drawn as you see. In addition, g of x reflects f along the x-axis. By reflecting, it's the very same scenario that I said. So since it is reflecting along the x-axis, it means the x-axis now plays the role of a mirror. And if it plays the role of a mirror, if this object reflects like that, such that we can picture maybe this point reflecting there, it would exactly be the same distance as it would be in that case, like that. The same mirror observation scenario, because it is reflecting about the x-axis. So that's what the whole concept of reflecting is about. Reflecting, rotating. It could have rotated. It's just that we are working in 2 dimensions, unfortunately. So another thing that I should add on, I think you guys already know, when we talk about the quadratic function, it has 2 forms. So a quadratic function or a parabola, you can take notes of this. Quadratic function or a parabola it has 2 forms that we can present it as at our curriculum. So we have the standard, which is the one that we know. F of x is equals to ax squared plus bx plus c. And then we have the second, which we can call this number 1. And then we have the second one, which we call this the vertex form. I think you are familiar with this probably. The vertex form is where we represent the very same equation can be represented in the form of fx is equals to a into x I will say plus or minus because there's a possibility of being a plus or a minus. P squared plus or minus Q. That's how a vertex form um, looks like. So you are able to move from vertex form to standard form, and you are able to move from standard form to vertex form. There are just a couple of things that you have to follow when you're moving from standard form to. So moving from here, moving from standard form to vertex form, the simplest way is to complete a square. So you complete the square to move from standard form to vertex form. However, the other way around, you just simplify. It's simple, you just simplify. But same equations are one equation is able to be represented in both ways, which brings us to our 6.1. 6.1, we are required to do 6.1 in vertex form. Do you guys want me to give you 5 minutes to try it first and then we try it together? I just want us to be participating. I don't want us to be relaxed. Flexibility, yeah. Do you want to try it? Do you remember? Do you remember how we did it last time when we were completing a square?
Yes.
Yes. All right. Please, get 5 minutes. Then we'll take it from there. We are allowed to be wrong, by the way. So I'm gonna give you 5 minutes. When you're done, you're just gonna send me pictures. I'm gonna see how you approached it differently, and then we'll take it from there. Ne?
Okay.
Okay. 5 minutes. Are you winning?
Almost done.
All right. All right. I think we have waited a long time now. If you are not done, it's okay. You can send the answers that you have. Let me just close the door here. Okay, okay, I see. Interesting. Interest. Interesting. Let me quickly wait for one more last student, just as quick as I just want to compare before I explain so it can have the proper punchline. I see, I see. But interesting stuff. Interesting stuff. Uh, by interesting stuff, it's a good it's a good thing. Not interesting stuff in a bad way. Like it means you guys are killing it. But there's some mistakes we can fix here and there. For some of you, I left you some comments, ne? Uh, just for the small again mistake that I see, I'm leaving a comment, je. It's because I know Huri. It's it's between us. It's just uh but we are doing the corrections anyway. So I'm just okay. But otherwise, I know that when coming to this thing of completing a square, you guys, you master it. So what we're supposed to be doing there, everyone got this step very correct, and I'm happy. So since we are given f of x is equals to minus x squared minus 6x, first of all, you don't want to have anything attached to x squared. Like for the value of a, it must be positive 1. So first step would be to take negative 1 out as a common factor. Then would be left with x squared plus 6x. And then the punchline of completing a square as it is, we have to add and subtract the square of half of 6. And the square of half of 6 is 6 over 2, which will be 3, and then you square. So you then gonna have x squared plus 6x plus 3 squared minus 3 squared. I'm sorry for going over the board there. And then from here, but so far everyone got these steps. And then from here you would have f of x is equals to minus, and then you do your thing, the main punchline of completing a square. So you take this x, you write it here, you take this sign plus, you take what is inside the bracket 3, you close your bracket, you square outside, minus 9. So here is where everyone might have got it a bit wrong for those who did. This negative, you come back, whatever value it would have been, even if it was not a negative, whatever value you have as a, you come back and you multiply the value of that coefficient of a outside by that value as well as by that value. So you treat that minus 1 as if you are multiplying it with everything with the brackets as well as with the minus 9, because that's how the situation is fairly. So you would then say f of x is equals to minus 1. You don't even have to say minus 1, just minus x plus 3, close bracket, plus 9. Do you see that? Guys, do you know that the vertex form is actually to help you get the turning point? Does any of you has a clue that the vertex form, you get the turning point from it? So this value and this value determine your turning point of that graph. But the way it works, if it's x and minus 3, we say the turning point will be minus 3 and 9. However, if the x was negative, then the turning point would be positive 3 and 9. The reason why we look at it like that is because, you know, if you have x plus 3 is equals to 0, if you are to take the x to the other side, it becomes a negative. So that's how we look at it when it's inside there. So if it's positive, you put it as negative in the turning point. If it's negative, you put it as a positive in the turning point. The reason why I'm telling you this is if you are still struggling from completing a square, it's not a problem, because I'm the guy who always tries to give you guys options so you don't get to struggle. So if you feel like this one is not for me, you can have another option as long as you know that these values are going to give you the turning point. You are allowed to can approach it like this. You say, okay, for me, I know that they say f of x, I must write it in the form of ax plus p squared plus q, right? You tell yourself, you know that already. From the given original function, there's something that is already visible for you. You can tell the value of A is -1. Do you agree?
Yes.
The value of A is -1. So you tell yourself that I know that PQ is supposed to be my turning point, meaning my turning point somehow is supposed to be minus P and Q. So I'm going to find my turning point. But I know that to find turning point, X is equals to B over 2A for the X value to find Q. X is equals to B over 2A because that's the way we find a turning point manually. So this would be your B is 6 according to the original equation. Your B is 6 over 2, your A is -1. So that would give you 6 over -2, which will give you -3. So you know that your turning point for, let me just put it like this. Your turning point for the X value, you already know it's going to be -3. Now you are looking for the Y part. And to get the Y part from the original function, you just say f of -3 is equals to minus 3 squared minus 6 minus 3. So there would get minus 3 squared. It would give us +9, but it would end up being -9 because of the negative outside. -16 minus 3 would give us +18, which will give us 9. So now you know your turning point is 9 and it's -3 and 16. So when you put it back in the form of ax plus b, just put the values as they are. F of x is equals to, since a is -1, you put minus, you open your bracket, x is going to be, now this one is a bit tricky, but not, remember the whole negative when you take it outside, positive when you put it back. So since the turning point, it came out as a negative, when you put it back, you're going to put it back as a +3 squared. And then the other part of the turning point is 9. Which one is easy? Completing a square or the second method? Which one
Completing
would
a
you guys
square.
go?
Completing square.
Completing a square. And this one is a bit complicated because either way, there's going to be a point where you are determining the turning point. If you master determining the turning point, if they say find the turning point and they give you the function, you can just brag and complete the square, and then you will have the turning point the way we extract it like that. But we know, Hori, sometimes when things are hard manually, this is how we find the turning point. We've been doing it like this, most of you guys. But just now that you are introduced to completing a square, maybe it's a grade 11 thing, but I know, Hori, we used to find the turning point using that way because we were avoiding completing a square because we thought it was complicated. But if you master it and you are happy with it, then that's how we roll from now onwards. Are we good?
Yeah.
Now, the next one, it depends on the confidence that you have. The next one, the whole story of A and B being symmetrical is coming to play now because we are required to get the coordinates of A. I think for me to end up doing this one, Yahori, you guys can do it on your own and you're going to send me the pictures. It's because you are quiet. But I feel if we want to save time, we can participate and do it together. Because I myself know how to do it. Or probably I don't. So let's just discuss it. Suppose I don't as well. We're going to discuss it, man. Can we try that? Just for the point A. The next one I'll do it myself because it's 5 marks. Since they are symmetrical, ideally, from what you see, remember, what do you think ideally point A is supposed to be before we even calculate it? Fact that if if point A and B are symmetrical, what does that say in terms of their values? Just that the line is not 100% straight. But does that communicate something to you, what I just did now? Does it give you a light bulb moment to say, oh, their values of y will be the same?
Oh,
Because if y is here, throughout, the value of y will be the same. So we might not know this value here, but we know their value of this one would be n, whatever n is. So we might not know this one. But whenever you are required to get the coordinates of anything, of a point, if a point is passing through the equation that you already have, you should celebrate because it's a good thing. If any point passes through any function that you already have the equation of, you should be happy because you can just substitute the values on that thing to get the value. So I think in order to get the value of n, in order to get the coordinates of A, we must first find that n because that n is similar for both. And to find n, we're going to use this point to find n because at least it has one value already. So from your equation of f of x is equals to minus x squared minus 6x, where there's y, we put n is equals to, where there's x, we're going to put minus 5 squared minus 6 minus 5. Therefore, there's going to be minus 25. N is equals to minus 25 plus what? Going twice, okay. 6 times, minus 6 times minus 5.
it's
Voice note.
30.
Okay, thanks. and then n will be positive 5, meaning n is positive 5. So that means where from that point of A, we already have one value. We know that we might not know what this point is, but we know this one is positive 5. So meaning B is 5. B is minus 5 and positive 5. And then A is 5 and something that we might not know. But still, we still have that equation. So we're going to use the point A now because we have one value from it. So from that equation for A, where there's x, I'm just going to leave it as it is because I'm solving for x. But where there's y, I'll put the value of n, which is 5. So 5 is equals to minus x squared minus 6x. Now, if I rearrange that, I would have minus x squared minus 6x minus 5 is equals to 0. And I will multiply by negative x squared plus 6x plus 5 is equals to 0. Then my factors can only be 5 and 1 and all positive. That part, I hope this part is not to worry about for now because we are old to can stress about factorizing. Ne? That's for small babies to worry about. If you struggle from factorizing, you're going to text me. We'll do it on the side or on our one-on-one lessons. Otherwise, x is going to be minus 5 and then x is going to be minus 1. So we already know the other side x is minus 1. So the one for minus 1 is going to be this one. Therefore, the coordinates of A will be minus 1 and positive 5. Easy peasy.
Yes,
The,
sir.
yes, the part which I thought like I just thought it could have been simple. Mara, the trick is every time you're looking for the coordinates of a point and the point is already through a graph that we have a function of, you take advantage of that graph to get the coordinates of the point. Every time when you have a graph that you don't have the actual, like you have a skeletal graph, it doesn't have the values, doesn't have the coefficient, but you are given point, you can use those points to somehow manipulate the math to end up getting the coefficient of that graph. So we use 2 points for an example. We use 2 points to get the equation of a straight line in the form of y is equals to mx plus c. But also, we use the equation y is equals to mx plus c to draw a straight line graph and determine any points we want from it. So it's a vice versa, the way forward and way back. It's reversible. But points complements equations. Equations complement points in terms for when you are fighting for your marks there, because in most cases, that stress suits are only one and we're just trying to avoid it. Determine the length of OE if CD is 14 units. OE if CD is 14 units. This one is interesting. Very interesting. For sure, you guys can tell this one is interesting as well. Eh? To cancel the spirit of looking at the question, and you know, one student was telling me, Hori, it was those cases when you are just starting lessons and they are explaining how challenging mathematics is for them. So they were telling me, Hori, Ishmael, sometimes I feel like there are some questions that are not meant for me. Like I just know this one is not for me. Like I just I just know for me I can solve this one, I solve this one, I get my 40%. These questions I just tell myself they are totally not at all. Do you guys have that? Do you have those type of questions where you feel like this one is not for me because when I kill that spirit in the name of Jesus or whatever religion you believe in, like in the name of
Yes.
whatever, like doesn't matter at home. Do you have those questions where you feel like this one, when I look at it, I just know it's not meant for me?
Yes.
Could 6.3 be those type of questions?
Mm,
Because in most cases,
kind of.
kind of, let's kill the spirit once and for all. Let's kill that spirit. All in all, through your functions, remember the main, I'm just removing everything because this one we need to look at it properly. All in all, the secret is not really on how you attempt the question. The secret still remains on the diagram. If we wanna determine the thingy, if we wanna determine OE, anything that has to do with OE, look at first size your OE and look at where it is. So your OE starts from O here up to E there. At least you must know what you have to calculate. So you have to calculate the distance from O to E. Somehow, these guys were fair enough. I don't know if you're going to look at it like that, but they were fair enough to give you this distance. And they say it's 14 units. I don't know how that is going to help you with. But the extra that you have a full equation of that graph. You have a full equation of that graph, such that before you even start, I think having the full equation of the graph allows you to at least have the distance of FO, or can call it FO or OF. At least I feel like you can determine the value of OF, or mean OF or FO, whatever I may call it, whether the other way around. Is there anyone who think it would be challenging to determine the coordinates of both F and O? Yes, no, maybe. So even finding F, it would be a challenge because you already know the coordinates of O. At least you already know the coordinates of O. Okay. What do you think would be the equation of G of X, if it is reflecting F of X? Anyone wants to attempt, given that you are allowed to be wrong?
But it's x squared plus 6x.
Because if it reflects, it's just, you just multiply by negative, because the other one, we all know that there's a difference when we have y is equals to ax, we're going to have smiley. But when we have y is equals to minus ax, we're going to have a set face in terms of the parabola. So there we have a smiley and a set face. So the set face is already the original graph because it had minus x squared. So meaning a is minus, hence it is concave down. So the concave up one, you just multiply it by negative throughout, and then you get your g of x. So g of x g of x is equals to x squared plus 6x. Now, when you get the length, you just looking at the equation. So this is f of x. Let me write it in green. This is f of x. This is g of x. Now, CD is the distance between C and F. And since CD is the distance between C and F, if we were to get the distance of CD, if we didn't know it, we would say CD is at the position where it is g of x minus f of x, because g of x at that position, that's where we have g of x minus f of x. Does everyone understand that part? At least.
Yes, sir.
You do, ne? Just by doing that, you have solved your problem. You have found the length of, because, okay, we just need from there, we need the value of x here when f of x minus g of x, the distance is 14. So where the CD is going to be 14, is equals to g of x, x squared plus 6x minus x squared minus 6x. And then you solve for x. One value there will give us what's happening, but let's see. We're going to have 14 is equals to x squared plus 6x minus x squared plus 6x. Therefore, or positive x squared as well. Therefore, this is going to be 2x squared plus 12x minus 14 is equals to 0. I'm going to divide by 2. I'm going to have x squared plus 6x minus 7 is equals to 0. Therefore, we're going to solve that. It's equals to 0. It's going to be straightforward. We're going to have x and x, 7 and 1, positive and negative. Therefore, x is going to be minus 1. X is going to, or the 7 has to be positive because the middle number, which is 6, is positive. So it will be positive 7, x plus 7, x plus 1. Therefore, I'm going to write the answers here. So x is going to be either positive 1 or x is going to be minus 7. So the length of OE, meaning the x value, the negative 7, since we already know this is minus 5 here, the x value from here to there would be 7 units. Look, there comes a point where you just adjust your mind and you accept things as they are. We had such questions in grade 10. I'm going to remind you, we had such questions in grade 10 where they would give us, maybe in trigonometry, they would give us one sine function and one cos function. And they say to you, determine the values of x, where f of x is greater than g of x. Something like that. And I don't know if you still remember, Mara, we used to find a way to work it out because we would know like, oh, g of x is greater here, then it's less here. We'd play around with the thing. This scenario, this punchline here, the way we open this question to say CD is equals to g of x minus f of x. It's very important for you to know some things, they start like that. Very, very, very important. Like that punchline is just to know, anyway, even if we get the distance in analytical geometry, we always subtract. Do you know that? It's about subtraction most of the times. So it's always going to be x2 minus x1. Even if you can say x1 minus x2, it doesn't matter, but it's mainly about subtraction. So that's why we got here. So someone could have said CD is f of x minus g of x. It could have led to the same thing in a way, but 7 units would be your conclusion, even if it could be a positive fail. We're good then, eh? And the only way we can eliminate that type of confidence of saying this question is not meant for me is to always go through such questions and avoid to do the ones you already know, which is the nature of how every student do. We know the beauty of, I am going to practice mathematics right now. And then you take your past question papers and then you go question 1. Then you solve, you solve, you solve, you solve. Maybe you're going to get 70% correct, 30% wrong. You repeat another question 1 on a different question paper. You repeat another question 1 on a different question paper. So it's been 45 minutes. The moment you go to question 2, your brain is just like, I'm tired. When you get to question 3 and it frustrates you, like, I'm going to see you tomorrow. Tomorrow you start again with things that you know. And that's how the nature of students is. Like, we enjoy doing things that we know, which is the reason why for those who are getting probably higher marks, they feel like they enjoy because they know more. So for us to avoid not knowing much and know more is to focus on this type of, Okay, let's make a deal. From today onwards, whenever you come across a question that you feel like it does not belong to you or is not meant for you, you send it to me. Now, then we're going to discuss it later, even if we discuss it with other students as well. Ne? Please, even if you
Okay.
don't answer, it's fine. It's okay. Even if you don't answer, but I know you are listening to what I'm saying. If you see a question from today onwards, is our goal. It's our new way of solving the biggest, scariest questions because they're the easier ones. Who cares? Then I selected these questions because I selected this one because as much as it's a grade 11 question paper, I gave it to some grade 12s. And from the way they behaved, I was like, hey, because parabolas are just parabolas, man. But clearly, it's those things that when we don't practice these things, we focus on things that don't matter too much. And the ones that matters too much, we do them at the last minutes. And by the time we do them at the last minutes, we don't have that patience to explain anymore because I just want to make sure you just know how to do it just to get marks, J. And it's not really about that. It's about observing this, like observation of this diagram. Like you can see there's more drawings on the diagram than they are on the thing. And look, the reason why I'm saying that is another student could have approached this differently. Remember, we have so many different methods. Another student could have approached this differently. Another student could have said, you know what? Let me find this distance. Then I'll be left with just this pushing to solve after, which when you look at it, you can fight for some Pythagoras there when you get there. I don't know, but for now, you can get OF because O is 0. So F is the x-intercept of the G. So to you, if I say x squared, I can even see it 6 units. X squared minus 6x is equals to 0. I take out common factor, multiplying by 0 throughout, so it's gonna be that. Take out common factor, x, therefore x plus 6 equals to 0. Therefore, x is going to be 0 or x is going to be minus 6. So you already know f is minus 6. So you already know one distance from here to here. You just left with that pushing space there. And you already know this one is 14 units, meaning one is 7, one is 7. You can fight your way from here, man. I feel like you would find a finder there. Like I'm just saying, you don't necessarily have to stick to approaching it like this. So it's a matter of the confidence of saying, you know what? When I have a question, I don't care what, like, but it's fine. Let me. For me, it's easy for me to say this because I've passed the grade. I've passed the grade long time ago, so that I even forget it exists. I'm only remembering it exists because we have to talk like this. But when you 5 years later, when you look back, you're gonna look back and be like, ah man, I can't believe the very same way you feel right now when you look at grade 8. At some point, grade 8 was a mountain for you. But now when you look at grade 8, even when a grade 8 students talk to you, when they like you feel like they can't relate to the work you have. Like for you, you feel like the grade 8 students can't relate to the work you have because you just have so much. There's algebra, there's this. But also, a first year at university, they might look at you like, I this grade 11 students, they think. So that's how, at that moment, that thing is heavy for you. But when you go past it, you look back, you're like, ah. So, um, one of the main thing that makes us to feel like this question is not meant for me. I said it's frustrating, dog, to do something that you don't like. There's nothing that's worse than, and now that's when Ugubekezela comes in because subjects like mathematics and physics, they require that. Like, look, man, some of the things that we learn in these subjects, we are not going to apply them in our workplace. But some of the subjects behind the maths, behind the X, behind the Y, they also teach you character, obedience, following instruction, all those little sort of things. Because when you get to your workspace, when you get to the way you treat people, the way you treat the world, the way, if you say you are educated, when you get to your workspace, it gets to a point now you are interacting with other people, you have managers, and now there has to be some level of respect. Not that respect of you are older, I'm younger, no, but that respect of not even by about position, but just respect of people you work with. Can you follow instruction? Can we give you something in the form of a paper and you create something like this, even if there was no one in the room, just following what is told? So all these things, they require patience. Patience is not because of an equation that is on a page. Like you can't be defeated by I mean, look, I can piss you off. Like I can say whatever I say, I can, but it's on a page. Even if you can just leave it there, like don't now feel like, oh, this thing. Like we create problems that are not even existing sometimes. So that's why I'm like, there is no problem that does not belong to anyone. As long as you look at it, you feel like it annoys you, close it. If it's not a force, if unless you are in class, you are writing a test. But if you are studying for yourself, you open it, it feels like it doesn't belong to you, close it, and then try it after 5 minutes. And then you feel like it doesn't still belong to you, and then it will be like carry pushing, but tell yourself for it. Dog. I mean, like there are so many things to worry about in life, unlike the academic world, and more especially if you have um like how do I say this? You have people like us also you can come to, but in hence I say most of us we have that nature of living like a student because we always say, if there's no test, there's no homework, there's no classwork, we don't feel the pressure of wanting to act on those questions that I feel like they are not meant for me. So you could have as much time as you can attempt those questions, but it doesn't really work out like that because we are they are not meant for me. But on the when you have exam in 3 days, test in 3 days, you now feel the need like let me focus on the ones that I can get marks on because these ones they are not meant for me, and then they're just numbers. They are not alive. They believe they are not meant for you indeed, and then the marks becomes which is that story. But anyway, from today onwards, let's agree, guys. Whenever you see that question, it's our new. Let's make it a trend. Whenever you see this question, whether you are in class, whether you are somewhere, take a picture of it, send it, and say this is that type of a question we talk about. The one that, regardless of what topic it may be, must always do that. I beg of you, please. Those are the questions we need to get fixed everyone's problem, so we can all get proper marks, distinctions all the time. Because look, of all the questions that we've done in this question, the one that has the highest value was the one that we thought is the most challenging, and there's nothing. So from the 16 marks, if you get that one wrong, you're already left with 11 marks. From that 11 marks, how sure are you going to get all of it? But confidence comes from there. So, but as much as I say it's not about marks, it's about the understanding. But the understanding helps us accumulate marks because at the end of the day, without the marks, there's no going to the next grade. But it's so beautiful to not pressure. Because if you want to memorize, no, you should have done history. What? So here, you went here because you said, I want to think. So while we are practicing how to think, we just have to be doing it all the time and consistent and consistent. Determine the values of k for which f of x minus x squared minus 6k will have a non-real. Look at what the funny thing is, it's taking us to something which I feel like you're already familiar with, aren't you?
Yeah.
Nature of roots. But this time around, you don't necessarily have to work around. Wait, I'm not sure if I should tell you what this. Let's just see. Let's see. Determine the values of k for which. So now 6.4.1, f of x is minus x squared minus 6x plus k. So it's the same equation that we had. They just added k at the end. I like your confidence when you said, yeah, do you want to try it? Okay, fair enough. Look, so Ankara, you must always look at it like this. For this type of question, to explain the real roots, remember, um, the real roots are explained in terms of the y value of the turning point. The y value of the turning point, which is q. So you already have your f of x is equals to minus x plus 3 squared plus q. No, 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 no. I said we are looking for the values of k. K is about x. So x is about x is about the x value of the turning point. But now because it's 2 marks, you don't necessarily have to analyze delta H. Then
Aren't we supposed to find A, B, and C?
but we do have, okay, if we find A, B, and C, we do have our A, B, and C. A would be minus 1, B would be minus 6, and then C would be K.
And then substitute it into what is it again?
The discriminant.
Yes, B
Yes,
squared
that's right.
minus 4AC, I think.
Yes. And then from here, B would be minus 6, minus 4, A would be minus 1, and C would be K. And then for non-real roots,
Delta must be less than 0.
delta must be less than 0. So therefore, you're going to do your thing and solve, and then it's going to be 36, ne? 36 minus 36 plus 4C, right? I mean 4K, because C is K, is less than 0. Therefore, K will be less than minus 9 if I simplify it. But that's not the point. That's not the point. Since K is less than minus 9, the point is, and I understand that's the answer, but I wanted to use the approach of the graph. On the graph, on our turning point, it's fine. I think I'm going to take it too far. It's fine. Because since it's 2 marks, I was thinking it's probably just something you point out and write it down. You don't necessarily have to go. But otherwise, thank you, man. That's I'm glad you still remember your paper too. I mean, you question one of the first paper, like that, the things we're doing there. But in the form of a function, I would like to explain it in that form, but that's another story. I think I'm gonna try to find a way, because also, unless we try 6.4.2, if we have time, and then we're gonna come back to this one, if I remember it as quickly as I can. The next one, same scenario. X plus K now will have 2 real roots that have different signs. Already you have f of x, so I just don't want you, before you even approach this, you have to create your new f of x plus k. You know how to do that, right? From your f of x. So from your f of x, which is f of x is minus x squared minus 6x, f of k, you just substitute the very same values inside. Okay, let's not use the graph. Using the same method that we did, do you think you can simplify this one and then we try it as at our own? And then we're gonna proceed maybe at some point, because like also now I'm no longer concentrating properly because I'm supposed to be having another meeting here, and I've pushed longer for this one because I knew we started a bit late. Let's try 4.6.4.2. We can take a screenshot from here. Tell me when you have the screenshot.
And then
All right. I will let you know if you're still free over the day, if we can have other lessons. Maybe we can have physics later. Like I say, it's a Saturday, and I also have like those university students as well. But when I finish what I'm doing, I'll be communicating to you one on the other side. Thanks for your time, man. I feel like lessons like this, they are sense because in a way we get to not worry too much about time, to a sense where if now I had to explain further, I could even buy time from the next person who's coming. But now, consistency also helps us to not limit ourselves, because if we do these things daily, imagine if we were to repeat a question like 6.3 at least 5 times, you would know it with your eyes closed. So the reason why we lack is because most of the things we don't touch them at all, and then got last minute rapenika, and we end up not reaching the work because I can't go to the text I can't go to write that text until I cover this part, You try to solve this one, you don't understand it, you move to the next one, you don't understand it, you get frustrated. You come here, I explain some things, you're like, I can explain, I can understand this in an hour, and then you just go and give whatever you give. Let's try a different approach for the last time. I beg. Let's try consistency, guys. I'm gonna push on my side, but you have to be available on your side. That's what we need. Consistency, Jay. Like one portion at a time, one portion at a time. Solve those bigger problems that are bigger than us. Then before you know it, those problems they become small. And you are aware, Hori. Nothing is big until you know it. The moment there were things probably more than, even for you to be able to get that those marks that you are getting now. There are some things that you used to think you're not going to understand, but now you do. No, no limiting ourselves. Let's enjoy the eating an elephant piece by piece. Thank you, guys. We can call it a day, ne? No, for now, not calling it a day completely. I like for now. Don't go MIA. Like okay, but no pressure still though. No pressure. It's up to your availability. As long as we've done something like this, now for a day, I'm satisfied. So whatever we do after, it's based on your availability. But I'm not pushing that pressure. The only pressure I can push is at least once a day. Whatever you do extra, it's your responsibility to eat as much as you want. Ne?
okay.
Yes, sir.
All right. I'm still gonna use this link for other things. You can just sign out. It's okay. Like I'm taking advantage of the network.
Yeah.
Yeah. Sure, Mr. Man, we'll talk. I'll tell you if you can have a one-on-one. Unless if you don't have any questions, you let me know.
Okay.
Oh, Lada.
Sure.
So yeah, man, for those who are watching on YouTube, today it was just, I didn't do it the way I normally do it in order, like, from there, just cut in between and we are here. But otherwise, look, man, if you want to be part of our group, feel free, send us a WhatsApp on 081-465-2676. That's 081-465-2676. You send us a WhatsApp and say, yo, man, I would like to join your group. You can join our group. We are like, we are more like a school, but at very reasonable fees. Other than that, look, not everyone can afford the private lessons. We still do such lessons where you can learn something, and you are also free to can send your question. If you have a question which you really want to discuss with me, maybe there, you can send it on the very same number on WhatsApp, which is 081-465-2676. We are here for you. You can't struggle alone academically. Otherwise, we make sure we simplify things for everyone because that's what we do best. And I mean, we are Simplified RSA, the guys who make it look easy. No one ever make it look easier than us in the world because indeed we are that. Wait for it.
Simplified RSA, the guys who makes it looks easy. Your number one learning channel.